So a couple of important points here as far as x plus y whole power n is concerned. This is the particular expansion. Now if I pick up the nth or r plus 1th term from this is a very, very important observation, a very, very important formula. In fact, this is your expansion itself. Very, very important. So tr plus 1 is equals to ncr into x power n minus r into y power r. This is your expansion actually. In fact, if you add all these terms, you will get the expansion. So if I do something like sigma ncr x power n minus r into y power r, where r runs from 0 to n, you will get this expansion, x plus y whole power n. This is actually x plus y whole power n. It can also be written as this, where you are adding all these terms. But remember, this is not your rth term, this is your r plus 1th term. That is very, very important, right? So you put r equal to 0 in this, you will get the first term, right? So you will get t1, first term. Likewise, you will have a t2, second term. You will have a t3, third term. How many terms will you have? N terms, right? In fact, you will have n plus 1 terms, not n terms, n plus 1 terms. Remember, this expansion, if the power is n, then this expansion has n plus 1 terms. That's very important, because r runs from 0 to n. So from 0 to n, you have n plus 1 numbers. So that's why 1, 2, and likewise this is your n plus 1th term. Remember, this is your tn plus 1, not your tn, right? So this is a very, very crucial formula. Actually, this is almost 40% of the chapter is this one formula itself. You just have to keep playing around with this formula again and again. So that's why it's very, very important that you memorize this. The other important point is, if your n is replaced with n minus r, then x plus y whole power n expansion changes to y plus x whole power n. So in this formula, t r plus 1, if I replace n with n minus r, if I replace r with n minus r, actually, what I wanted to write was, if not n, if your r is replaced with n minus r, then the formula changes to r n minus r into x power n minus r, which is x power r, into y power n minus r, right? Remember, nc n minus r can also be written as ncr, right? So these both are the same. We'll see later, due to the properties of coefficients, we'll see how these two are equal, but for now just accept that these two are equal. So I can replace this with tr plus 1 equals to nc n minus r can be written as ncr into y power n minus r into x power r. As you can see, when you had this formula as ncr into x power n minus r into y power r, then it was x plus y whole power n. But now if you have y power n minus r into x power r, it will be y plus x whole power n, right? But what I mean to say is, if you replace r with n minus r, the only thing that will happen is this will become your first term, this will become your second term, and this will become your last term, right? But the expansion will just get reversed. Nothing else will happen. The final sum will remain the same. So these are a few important points as far as the expansion is concerned. Let's move on to the next subtopic.